Hi everyone, my name is Malte. I'm geologist at Norske, and I will take you up to the north and talk about deep geothermal energy in Svalbard. I'm presenting this on behalf of me and on behalf of the whole project team consisting of people from UNIS, the University Center in Svalbard, GTML, Geothermal Energy Nordic, and Norske. So let me take you up to the north to Svalbard at 78 degrees north. I will talk about the geothermal potential in Svalbard in general. I will present you our ongoing concept study on a geothermal plant in Longyearbyen. I will talk about what we learned about advantages and challenges for geothermal projects in Svalbard. I will present what possibilities there are and what our vision is. 2013 to 2016, Norske together with Christian Mikkelsen Research, now Norse, here Kirsti Midtømme, you see her on this picture, and Nursha had a pilot project, and the goal was to map the geothermal potential on Svalbard in general. We dug deep into the archives of Norwegian and international oil and gas companies that have been drilling on Svalbard for oil and gas, and we found that quite some data exists from many places on Svalbard. Here on this picture you see a plot from these hydrocarbon wells, depth to the left and temperature to the right. Found out that the geothermal gradient varies quite a lot throughout Svalbard and is in generally higher than on mainland Norway. In addition to those data, we also installed thermistor strings in our coal exploration drill holes. We did the evaluations of the geothermal potential for the main settlements in Svalbard, which is Ny-Ålesund in the north, Barentsburg, Russian settlement close to the western coast, Longyearbyen in the center of Spitsbergen, and a bit to the south, Sveagruva, which now is about to be decommissioned, so this town won't exist anymore in a few years. A little bit about the results. Ny-Ålesund in the north. The subsurface geology is quite little known. It's just within the fold and thrust belt. The geothermal gradient is also not known very well. The closest drill hole is 24 kilometers away in this area, and there the gradient is just 25 degrees centigrade per kilometers. The energy supply today in Ny-Ålesund is diesel, and they have a waterborne district heating system. Population is very low, 35 in winter, and in summer up to 120 researchers. The town of Longyearbyen, the main settlement in Svalbard, is the biggest town with the biggest population with 2,400 inhabitants. The geology in the subsurface is quite well known through to scientific and hydrocarbon wells, very close by or in the distance of 17 to 34 kilometers. But down to 1 kilometer depth, we have a very good knowledge about the geology, thanks to the Longyearbyen CO2 project, which was run by UNIS. Longyearbyen, or below Longyearbyen, we have normal to high gradients. That means between 30 and 44 degrees centigrade per kilometer. Today, the energy supply in Longyearbyen is coal and diesel. It's a waterborne district heating system installed in the whole town, and it is decided that the coal power plant will shut down within the next 4 to 5 years. In Barentsburg, the Russian settlement in Svalbard. The subsurface geology is not very well known. It's close to the fold and thrust belt, and there might be quite some surprises. The geothermal gradient might be known down to a depth of around 500 meters because they have coal mining there. But we didn't get any good data from the Russian coal mining company. From the well in Coles Bay between Barentsburg and Longyearbyen, we know that the geothermal gradient is quite normal, 28 to 30 degrees per kilometer. Barentsburg has coal energy supply with district heating and a population of roughly 400 persons. Now to the ongoing concept study. For some years now, Norske had ambitious plans to run a project drilling 3,000 to 5,000 meters deep with the aim to supply the whole town of Longyearbyen with the geothermal heat. It showed that it is very difficult to finance such a project because the first well is always the well with the highest risk, and even if you succeed the first well, there is no more market for another well in a similar town with a similar geology because there is just one town. So we thought we have to downscale, and we had a project. Norske is going to build a new school building in Longyearbyen, and with the partner GTML, Geothermal Energy Nordic, the company that has realized the only deep geothermal wells in Norway. We had a perfect partner with great knowledge, and we also have the experts for subsurface geology and permafrost in Longyearbyen, which is the University Center in Svalbard, UNIS. So we decided to go for this. We applied Enova for funding, and we got 0.8 million kroner for this concept study. Total budget for this small project is 1.8 billion kroner, and we aim to finish it in January next year. We go for a very low risk as possible project to give it a geothermal start in Svalbard. So we plan a deep borehole heat exchanger without any interaction with the rock. The project looks like that. Here, if for those people knowing Longyearbyen, this is the road towards the airport. Here towards mile 7, here is the city center, and just close to the river outlet, the new school building will be built. Norske will build this one. And here you see the existing student housing, which will be a part of the new building, and the new building will be set up just north of it. Here you see it as the bird would see it. So the whole building will use roughly 500,000 kilowatt hours thermal per year, and the maximal thermal energy need is roughly 150 kilowatts. So what do we learn, and what did we learn during our project? What are the advantages for geothermal energy for a town such as Longyearbyen? General, Longyearbyen has the highest population in Svalbard, higher than other towns, 2,400 inhabitants, which gives a good market. It has a coal power plant, which is shut down latest in 5 years. The future energy source is not defined, and this power plant, which you see here, it produces 12 megawatt electric energy and 16 megawatt thermal energy. As mentioned, there's an existing water-based district heating system for the whole town, so this doesn't have to be built up from scratch. And the town lies in the high Arctic. That means there are low temperatures throughout the year, which also means heating is needed throughout the year. This picture shown here shows Longyearbyen during 16th of August. Typically from middle of August there is snow on the mountains for the first time. On this picture you see the sun diagram for Longyearbyen. It shows that there are 4 months of darkness. That means competing energy sources or as solar energy are not available during the winter month. Geothermal energy with a constant heat supply throughout the year is also there a big advantage. In general, high energy prices in Longyearbyen for electric energy, you pay between 2 and 2.5 kroner per kilowatt hour. As mentioned, Longyearbyen has the best mapped subsurface geology in Svalbard, and as you see here, we have a high geothermal gradient up to 44 centigrades per kilometer. Looking at the depth of 900 meter drilled in Longyearbyen and comparing it to Gardermoen, we see that Gardermoen has 17 degrees centigrades while Longyearbyen has 32. In a depth of 1500 meters, we expect 55 degrees centigrades in Longyearbyen, while in Gardermoen there are measured 27. Another advantage is that actually Longyearbyen is in a very dense valley, in a very narrow valley, and is very densely populated. And the areas where there are no houses are normally cultural heritage. So there's little space available, and the geothermal power plant requires only very little space. So what are the special challenges for cheap geothermal energy in Longyearbyen in the high Arctic? There is the permafrost. This line here shows measured temperature at the area where the school building is supposed to be built. You see that just below the surface we have minus 3.5 degrees, and if you extrapolate this line, which is from a drilling down to 70 meters, you meet the 0 degree isotherm at roughly 90 to 100 meters. The ground or the ground is salty, which means it might thaw already at the temperature of 1.5 degrees minus. So this is a challenge which we have to deal with. We know from the coal mines, which you can see here in this picture, that even in depth of 50 meters, we have ice-filled cracks, and if this ice would melt, the rocks could move and would destroy the whole infrastructure. So what do we do to prevent this? We plan with active freezing around the casing, which goes through the permafrost layer, the frozen permafrost layer. We have sedimentary rocks in Svalbard. That means we have gas, we have under pressure, we have porous rocks, we have fault zones. That means that we need a oil drill rig with a BOP, with a blowout preventer. And for this project, we avoid karst and we develop a completely closed system with no interaction with the rocks. Drilling machine or drill rig looks like that, trailer based. And now we plan, because we want to avoid any karst, we plan to drill 1200 meters deep. Another challenge is that there are high logistics and mop-demop costs in Longyearbyen. Everything has to get up by boat, and if you need a spare part, it also has to be sent up. In addition, we have a very harsh winter, and as mentioned before, a very small market. So what are the possibilities on Svalbard and what is our vision. As mentioned, this is work in progress, but we hope that we find out that this is economic feasible and that we will realize the first geothermal project in Svalbard for this new school building during next year already or in 2023. Then we want to investigate larger geothermal systems, which you can see here to the right. Enhanced geothermal systems where you stimulate the rock, existing hydrothermal systems, which we know exist, or even deeper borehole heat exchangers, which can be drilled vertical or also with a high horizontal component. And here we think about depth down to 6,000 meters. So we'll investigate those possibilities with the aim to supply the whole town of Longyearbyen with it. We know here you see the subsurface geology below Longyearbyen. So we want to realize this full-scale plan. We have, as you see here in blue, we have some targets which are not very deep. Karst here in the Ipstein group and Kapstadsing can be very porous and permeable. And there are other targets even further down. Idea is that also surplus energy which is produced during summer can be used to supply some electricity with organic Rankine cycle. And then Norske has the aim to establish similar systems other places in Svalbard. And in the Arctic, there are many places. A study shows that around 1,500 settlements and stations are basically run on fossil fuels, very expensive, and there we think we can do quite some change if we develop a good system and can deliver from scratch with geothermal energy, wind power, solar power, and battery storage, heat storage. With this, I would like to thank you for your attention, and please, you're welcome to ask questions.